Welcome to Lesson 1G, Absolute Value Inequalities. I can represent the solution of an absolute inequality on a number line. So when we're talking about absolute values, the absolute value of x equals 3 means that the point x is exactly 3 units away from 0 on the number line. So what does the absolute value of x is less than 3 represent? Well, that means that the absolute value of x less than 3 means that the point is less than 3 units away from 0 on a number line. So if I'm thinking about 0, points that are less than 3 units away from 0 on the number line are points within this range here. Because it's so negative 1 is still less than 3 units away from 0 on a number line. So is negative 2, so is positive 2. So it's this grouping right here. So when I'm setting this up, if I have the absolute value of x is less than a, where a is a positive number, then the absolute value of x is less than a is equivalent to negative a is less than x is less than positive a. It ends up being an and statement, right? So if I've got the absolute value of x is less than 2, this becomes, I can drop the inequality and make this negative 2 is less than x minus 8, which is less than 2. I add 8 to all sides, so I get 6 is less than x, which is less than 10 for my final solution. That's how I'd get the x isolated. Before splitting apart the inequality, we always have to isolate the absolute value part before we begin. So what I'm going to do here is I'm going to subtract 6 over to get that the absolute value of 3x plus 2 is less than or equal to 7. And at this point, I'm able to rewrite this as an and inequality. Negative 7 is less than or equal to 3x plus 2, which is less than or equal to 7. I subtract 2 from all sides. I get negative 9 is less than or equal to 3x, which is less than or equal to 5. Divide by 3. Negative 3 is less than or equal to x, which is less than or equal to 5/3 is my final answer. Okay, moving right along. Those weren't too bad. Let's do some slightly harder ones. Again, I have to isolate the inequality first, so I'm going to start by subtracting the 9. So I get 2x minus 3 over 4 is less than negative 4. Now pause. You know something about absolute values, and it's that absolute values are always positive because they're distances. It's a distance from the number line. So because my absolute value, so write this in your notes, guys, absolute value cannot be less than a negative number, that means that this guy has no solution. So let's take a look at another one of these. This guy, my absolute value is already isolated. That number is positive, so it's okay for me to work with. I'm going to split it up into an and inequality. Negative 11 is less than 2n minus 3, which is less than 11. Add 3 to all sides, so I get negative 8 is less than 2n, which is less than 14. Divide by 2. Negative 4 is less than n, which is less than 7. Not too bad. This guy, I need to isolate the absolute value again, so I'm going to subtract 8 from both sides, so I get the absolute value of x plus 9 is less than negative 4. Again, because this is a negative 4, our inequality cannot be less than a negative number, so my answer is no solution. Taking a look at E, I'm going to subtract 1 from both sides to get the absolute value isolated. 1/3 x minus 2 is less than or equal to 8. I'm now going to split this up into into 1 and inequality. Negative 8 is less than or equal to 1/3 x minus 2, which is less than or equal to 8. Add 2 to all sides, so I get negative 6 is less than or equal to 1/3 x, which is less than or equal to 10. Multiply everything through by 3 to get rid of the 1/3. I get negative 18 is less than or equal to x, which is less than or equal to 30. Very nice. All right, let's take a look at F. I want to get the absolute value by itself, so when I do that, I'm going to subtract 3 from both sides, and I get 0. Now, stop. When you get 0, the absolute value of a number can be 0, but it cannot be less than 0. So because I've got less than or equal to, this will only be true. This is only true when 2x plus 6 equals 0. It is not true for when it's less than 0, so it becomes an equation rather than an inequality. And I go ahead and I solve it. I subtract 6, divide by 2 to get that x equals -3 is the only possible solution to this equation. So moving right along, let's take a look at another section now. Now let's consider the absolute value of x is greater than 3. By the way, my symbol here needs to flip. The absolute value of x is greater than 3 means that the point is more than 3 units from 0 on the number line. So points that are more than 3 units from 0 on a number line, well, certainly from 3 and up, 4 is more than 3 units away on the number line, so is 5. And then from -3 down would also satisfy that. So when I have an absolute value is greater than a positive number, we can split this up into an OR inequality with 2 pieces, where x is less than -a and greater than a. So let's take a look at this. If I have the absolute value of 9 is greater than 4, I can split this into 2 inequalities. The absolute, or x minus 9 is greater than 4, or x minus 9 is less than -4. I add 9, so I get x is greater than 13, or add 9 over here, x is less than 5. And this compound inequality is my final answer. Just like before, we're going to have to isolate our variable, or our absolute value, before we're able to split it up. So I'm going to start off by subtracting 10 on this side. So I get 2x minus 6, absolute value of that over 5 is greater than or equal to 20. I'm now going to multiply by 5 to get the absolute value by itself. 2x minus 6 is greater than or equal to 100. Now that I've got it in this format, it's a greater than equation, so I can split this into an OR inequality. So I'd have 2x minus 6 is greater than or equal to 100, or 2x minus 6 is less than or equal to -100. And we're going to solve both of them. Add 6 to this side, so I get 2x is greater than or equal to 106. Divide by 2 to get that x is greater than or equal to 54. Or on this side, add 6 over here to get 2x is less than or equal to -94. Divide by 2 to get x is less than or equal to -47. So my answer is the compound inequality. X is greater than or equal to 54, or x is less than or equal to -47. Let's take a look at C. I'm going to start off by subtracting 8 to get the absolute value by itself. So 3x minus 7 is greater than -6. Pause. Whenever we have a negative or a 0, I always want you to pause and go, wait, what's going on? Now, absolute values have to always be positive, and all positive numbers are greater than -6. So because absolute values are always positive, this means that they're always going to be greater than a negative number, no matter what you put in for the x, which means that my answer here ends up being all real numbers. No matter what I put in for x, anything in this absolute value will churn out a positive number, which will always be greater than -6. So that one's kind of fun that way. So let's keep looking at some more. Right here, I've got the absolute value of 3x minus 6 is greater than 12. It's already isolated, so I can go ahead and split it up. It becomes 3x minus 6 is greater than 12, or 3x minus 6 is less than -12. Solve both. Add 6 over here to get that 3x is greater than 18, or x is greater than 6, or I'm going to add 6 over here to get that 3x is less than -6. Divide by 3 to, coming back. to get that x is less than negative 2. So my answer is 3x is greater than 6, or x is less than negative 2. E, I need to do a little bit of work to get it isolated before I can start. The absolute value of x plus 1 over 2, I'm going to add the 3 over to the other side to make that less than or equal to 7. And at this point, I can split it up into two inequalities. So I can say x plus 1 over 2 is greater than or equal to 7, or x plus 1 over 2 is less than or equal to negative 7. Multiply by 2 to clear the fraction, so I get x plus 1 is greater than 14, or x is greater than 13 when I subtract the 1, or my other side. Multiply by 2 to clear the fraction, so I get less than or equal to negative 14, and then subtract the 1 to get the x by itself. X is less than or equal to negative 15. So my final answer is this lovely OR equation. X is greater than 13, or x is less than or equal to negative 15. All right, F. On F, I'm going to start off by subtracting 9 either side to isolate the inequality. So I get 5x plus 7. Absolute value of that is greater than negative 6. Pause. We just got a negative. That means we got to stop and think a little bit. Greater than negative 6, all absolute values are always positive, therefore they're always greater than a negative. So my answer is the very easy, all real numbers. And on G, let's take a look at this guy. The absolute value of x minus 1 is greater than 0. Well, as all absolute values are positive, any number I put in there, except something that makes it 0, is going to be greater than 0. So this is always true, except when the x minus 1 happens to equal 0, because that would break this, right? It's not greater than or equal to, it's just greater than. So my answer has to be x minus 1 cannot equal 0, therefore x cannot equal 1. X cannot equal 1. All right, let's take a look at a summary of this real quick. So there are basically 3 big instances of absolute value equations. The first is when we have the absolute value of x equals a. That will become 2 equations that you'll then solve, x equals a and x equals negative a, and you'll go from there. When you have the absolute value of x is less than a, that's going to become an and equation. It becomes negative a is less than x, which is less than a. You join them together, it becomes they're one nice inequality. Whereas if I have the absolute value of x is greater than a, this is going to become an OR equation. Greater is an OR. So I would get x is greater than a, or x is less than negative a. Greater is or, less than is and. Now, here's the big old caveat. If you get 0 or a negative number on the other side of your absolute value, or once your absolute value is isolated, you have to stop and think. Now, I'm going to make a chart here with you of the instances that this can happen and what it's going to be, but it's better if you just take a moment to stop and think about the solution rather than trying to memorize this thing we're about to go through. But let's take a look. So what if you get the absolute value of x is equal to 0? Well, that means that simply x happens to be 0. If you get the absolute value of x is equal to a negative number, that means there is no solution because your absolute value can never be negative. All right, so that's when we've got our equality going on. Now let's look at less than. Okay, if I've got the absolute value of x is less than 0, this is going to be big old fat no solution because the absolute value can never be negative. Whereas if I've got the absolute value of x is less than or equal to 0, this is going to end up being just x equals 0 because we can't have any of the negative solutions, but I am including the solution where x is 0. And if I get the absolute value of x is less than or equal to a negative number, this is going to give me no solution because the absolute value can never be negative. So that's our less than situation. Now let's talk about our greater than situations. If I get the absolute value of x is greater than 0, this guy is almost all real numbers except where x is not, except where x is 0. Because we're saying we'll take any number at all, except that where x is 0. So we have one exception. Whereas if I have the absolute value of x is greater than or equal to 0, this ends up being all real numbers because all absolute values are either 0 or greater. Then if I have the absolute value of x is greater than a negative number, well, as all absolute values are positive, this produces all real numbers as a result. All right, guys, so those are your weird exceptions. Again, don't memorize them, just think through them, but you have them. And then this is your general rule. So if you remember one thing from this lesson, I want it to be this right here. Remember that. This is your big idea. Highlight it, star it, whatever you need to do. That's your big idea. All right, guys, thank you very much, and take a look at the practice problems.